on day 3. Let me zoom in a little bit here. So day 3 is now all of the things that we learned with square roots, we're going to work through with cube roots. So cube roots just make it a little bit tougher because you have bigger numbers and you have a little bit tougher rules to follow. Okay? So why don't we get started with, you can extend the product and quotient properties of square roots to other radicals such as cube roots. But when using these properties of cube roots, the radicands, which means the things under the radical, can have negative numbers. So that's one of the biggest differences. You can have negatives under cube roots. So don't let it get in your head that that's a no solution. Okay? But in order to break down cube roots, you need to know your perfect cubes. So this lesson, if you aren't good still with your division, you still have your calculator. You can test. I know kids struggle sometimes with, I don't know what goes into 135 or what goes into 729. But you have a calculator, and you take these numbers and see what goes in evenly and then run from there. Okay? So the first 10 perfect cubes are 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343. Ooh, I don't know what 8 cubed is, so I'm going to quick type it on my calculator. To do 8 cubed, I can use my phone as a calculator. So I go into Desmos and go 8 cubed. It's 512. So 512 is 8 cubed. 9 cubed. So 9 cubed is 729. And 10 cubed is 1,000. So there's the first 10 perfect cubes. So to start out with, you want to break down a cube root, you got to split it apart. So I would look at 135 and see if 27 would go into it. So 135 divided by 27 is 5. So that's going to be my breakdown. I'm going to break down as the cube root of negative 27 times the cube root of 5. And the cube root of 27 is 3. So the cube root of negative 27 is negative 3. So that's negative 3 and then cube root 5. So it's the same as square roots. You just have a little 3, and you're dealing with perfect cubes, not perfect squares. Okay? 729 is a perfect cube. The cube root of 729 is 9. So I'll circle my answers for you guys so you can see them. 3, 216 is up there. So 216, the cube root of 216 is 6. All right, now watch. There's a couple ways to do this, right? You have to know that you think mentally about the letters and the powers, but you have to think of, I have 4 W's, all right? And if I took 3 of those W's and pulled them out under the cube root, so I wrote it as cube root W cubed, and then cube root, how many W's are left? If I took 3 of them, I'd have 1 left. Well, then what's the cube root of W to the third is just W. They cancel. And then you're left with the cube root of W underneath. So that's the long way of doing it, is you just break it apart. How many perfect cubes can you pull out? But in the world of math, it's division, all right? And I keep telling you guys, if you know how to divide, you can do this. And kids are like, oh, I don't know how to do it. I'm like, do you know how to divide? Yes. Then divide. How many times does 3 go into 4? It goes in 1 time. So 1 full time. So you pull that W out. That's W to the first. And there's 1 under the root. So it's just division. You just divide the powers by 3. Okay? All right. Number 4, I've got a negative out in front and cube root 192z to the 5th. So I don't know. I think maybe 64 might go into it. So I'm looking for 192 divided by 64. Yep. So 3. 192 divided by 64 is 3. So even I got to use my calculator to figure that out, guys. So I'm going to break it apart as negative cube root 64 times, well, that's a negative out in front, cube root, I said it goes in 3 times, and then you still have the z to the 5th. So watch. Cube root of 64 is 4. Now let's do the letters. How many times does 3 go into 5? It goes in once, so I have a z to the first, but I don't write the 1. And then what's left is the cube root of 3z squared. Okay, so you split it apart and then do your little trick with the letters. And that's our final answer. That's in simplified form. Okay? All right. 5, I'm going to break it apart as negative cube root of 1,000. I can pull the negative out. And then that's times the cube root of 9. Don't get fancy and think that's 2. And then I have x to the 14th under the cube root. So the negative cube root of 1,000 is negative 10. Okay, here we go with powers again. How many times does 3 go into 14? It goes in 4 times. So that's why I have an x to the 4th power. What's left is the cube root of 9, and I have 2 x's left, so x squared. How did I do that? 3 goes into 14 4 times, remainder of 2. And you're done. So the letters to me are the easy ones. The numbers are the hard ones. Okay, what goes into 56? 8 goes into 56. So I've got negative cube root 8, cube root 7, and we can do the letters later. So cube root of negative 8 is negative 2. Now let's do the letters. How many times does 3 go into 9? It goes in evenly 3 times with no remainder, so there's no remainder for x. And 3 goes into 11 3 times, so I have 3 y's, but I'm going to have 2 under the remainder. So I have a 7 is left over as a cube root, and 2 y's. Tricky. Well, we don't have much room for this page. Yikes. I'm going to have to work a little bit more sideways. What do you do with fractions? Well, with fractions, you can break them apart as top and bottom. Okay? So I'm going to take the top fraction and write it as cube root 125 cube root 2x to the 7th all over, and then the cube root of 343, that's up here, that's 7. Now I can simplify. Cube root of 125 is 5. Now do your x trick, right? X to the 7th. So how many times does 3 go into 7? It goes in 2 times with a remainder. So my remainder is still under the root. So I have a 2 and an x because there's a remainder of 1, and that's all over 7. Now the rules are simplified, but it's debatable if that's more simple or not. To me, it looks more complicated when it's written like that. But the better word would be lowest terms. It's in lowest terms. That's how it works. Okay? All right. Yeah, with number 8, it looks like we can simplify before we multiply. So let's simplify before we multiply. So under the cube root, in the numerator, I'll have negative 2a to the 8th, and then the denominator, I'll just have b squared. Oh, maybe simplifying made it worse. Yeah, simplifying might have made it worse. Maybe we cube root the denominator, trying to find the simplest way to do it, but now I can't do anything with my denominator. So maybe the simplest way to do it is to leave or just root the denominator right away. So we'll cross that off. So we'll break apart the numerator as the cube root of negative 8 times the cube root of 2a to the 8th b. And then in the denominator, cube root of 8 is 2, and the cube root of b cubed is b. So maybe that's a little bit more simple. Okay? Then I can cancel this, right? The cube root of negative 8 is 2, so 2's cancel. If you can't see that, the cube root of negative 8 is 2. So the 2's cancel, and I'm just left with a negative. And then I'm going to pull my a's out. So how many times does 3 go into 8? It goes 2 times. So my numerator is a squared, and then I have the cube root of 2a squared b all over b. That's tough, but fun. I think these are fun. I like the challenge. I like the mental toughness of it. If you guys take on that challenge, it'll be good for you. Okay. Okay. Number 9. I'm going to root the bottom because I know 512 is a perfect square because it's on my list. It's up there. 512. So the numerator, 12, there's no number that goes into 12. So my numerator is just root 12a to the 6th. And my denominator, the cube root of 512 is 8. And then the cube root of b to the 9th, right? 3 goes into 9 3 times. Okay. Oh, that's cube root. Now I have the a I need to take care of. 3 goes into 6 2 times. So watch. You have an a squared and then root 12 over 8b cubed. It's awesome. Awesome, awesome, awesome. All right, number 10 and 11 are designed to this thing called rationalizing. So this is where I showed you guys a shortcut on day 1, but your Algebra 1 teachers may be like, oh no, don't show them the shortcut. It ruins them for cube roots. Well, I figure if you can do square roots easy, at least you got square roots down. Now, cube roots are something different. You can't use your shortcut. You have to use your brain, and you have to think. It's not that complicated. You just need perfect cubes, all right? So I'll just show you. And then pause the video and raise your hand if you have questions, or email me if you have questions, but I'm thinking perfect cubes in my head, okay? Well, I have a 4. What would be awesome is if that's an 8, right? If that was an 8, we wouldn't even need to rationalize because the cube root of 8 is 2. Well, all I'm going to do is multiply by something that does make it an 8. What if I multiplied by the cube root of 2? And when I multiply them together, I get 8. But whatever I do to the bottom, I got to do to the top. Okay? Right now, that's x squared. What would be awesome if that was x cubed, right? If that was a 3, it'd be like, dunzo, we're done. But it's not. Well, I have 2 x's. How many more x's do I need to make it 3? I need 1 more. So you can't just use your shortcut. You have to use your brain. What would make it perfect? Okay? So now watch how this works. In the numerator, you just write what you see. You have 7 cube root 2x. And in the denominator, make your calculations. You have 4 times 2 is 8, and the cube root of 8 is 2. You have 3 x's that are under a cube root, so they'll cancel each other down to 1x, and you're done. I think those are kind of cool. You're doing some math now, right? You freshmen, you guys are cranking out some math. I love it. All right, let's do this one. Tiny little font, but you got to pick. You got the notes in front of you, so you can see what we're doing. All right, so I'm going to multiply, and I just got to think it through. I always tell myself, what would be awesome if? Well, what would be awesome if that 25 was one of those numbers up here? But it's not, okay? So I got to think of the easiest number that I could get to with 25 through multiplication. Well, I don't want to get to 27. I can't times anything to get to 27. I can't get to 64, but I can definitely get to 125 if I times it by 5. So I'm going to take, and I'm going to times the denominator by 5, but whatever I do to the bottom, I got to do to the top. So that's going to get rid of the bottom cube root. Now let's think of the m's. What would be awesome if I had a multiple of 3 for my power of m, right? If I had a 3 there, that would be perfect, but I got a 4. So dang it, 4 doesn't go evenly to 3. What does go evenly to 3 is 6. So if I have 4, how many more m's do I need? I need 2 more. That's awesome. Now you take the numerator and just put it together. It's like an omelet. You got your little bacon and ham and eggs and cheese. You just kind of hammer it all together. And then in the denominator, let's use our brains. Let's think about this. This is cube root 25 times 5. I times it by 5 so I could get to 125. And the cube root of 125 is 5. Well, I have 4 m's and 2 m's is 6 m's, and I cube root it. That's division. 6 divided by 3 is 2. And we're done. Just like that. Don't forget your little cube root symbol. I see that all the time with kids. They just square root. It's cube root. It's good stuff. There's a back page. Can't believe there's a back page, right? All right, I'm going to start going a little quicker. You can pause the video as needed, okay? So this is cube root 2 16ths over x. I'm going to reduce my fraction. There's little tricks you figure out as a math teacher. So I'm going to reduce my fraction as 1 over 8x. And I can do the cube root of 1. The cube root of 1 is 1. And I can do the cube root of 8 is 2. But I still have this cube root x down here. Can't have cube roots in the bottom. That's what we're practicing. So then I'm going to do what would be awesome. So what would be awesome is if I had 3 x's. If I had 3 x's here, I'd be all set. How many do I have? I have 1. Well, let's just add in, sprinkle in 2 more over here. But then whatever I do to the bottom, I need to do to the top. So I'm going to put 2 up there and then put it together. So in the numerator, I just have cube root x squared. But in the denominator, I've got a 2. And then the reason I put 2 x's here, so I could add to that one, that makes 3. That cancels the cube root. You're just left with an x. Dunzo. That's kind of fun. All right, adding. You can't add unless they are alike. So let's see what we got here. I'm thinking 216. So that's one of my choices. I look back there, I remember 216, and I want it to be root 2, and I cut it in half in my head, and that's 216. So I'm going to do the cube root of negative 216 root 2 plus 8 cube root 2. Cube root of negative 216 is negative 6. So I have negative 6 cube root 2's plus 8 cube root 2's. And if we say it out loud, we can combine it very easily. If I have negative 6 of those and 8 of those, when I add them together to make them more simple, I just have 2 of those. So I have 2 cube root 2's. Awesome. Oh boy, 14. Here we go. Let's see what we got going on here. I just have to subtract them. So this is in lowest terms because the power of 2 is too small to cancel and the 4 is not a perfect cube. So I'm betting I've got to simplify that a little bit. So 4 goes into 108. 27 times. So here we go. This is 5 times root 27 times cube root 4 m squared minus 18 cube root 4 m squared. We'll do some mental math. Cube root 27 is 3, 15, 5 times 3 is 15. So this is 15 cube root 4m squared minus 18 cube root 4m squared. And when I combine my like terms, that's negative 3. So I have negative 3 cube root 4m squareds. That's good stuff. Multiplication. Multiplication ain't no different. Is no different than square root. You just have cube roots. But you should simplify before you multiply. So I see I can add these together here because in my head I know that 27 can be split up as cube root 2 and I can make it more simple inside. So I have the cube root of 7. Now this is cube root 27 is 3. So that's 3 cube roots 2 plus 11 cube roots 2. If you don't know what I did there, I skipped a step. I just wrote the cube root of 54 is 27 times the cube root of 2. That's all I did. I just did it in my head. I just did cube root 27 is 3. You don't have to write everything down. If you can do it in your head, that's amazing. Take advantage of that. So inside the root or inside the parenthesis, I have 14 cube root 2. It's kind of ugly, right? When we multiply, now I have to multiply this times that. Well, the number out in front is a 1. So this is just a lot of things going on. But that's the name of the root. That's under the root. This is the 14 outside. So outsides times outsides. 14 times 1 is 14. And then inside, 7 times 2 is 14. So that's 14 cube root 14. It's ironic that it's the same number. It's not always like that. All right. 16. I think we can break apart the inside. So we've got cube root 2, parenthesis. This is 8 times 3. So the cube root of 8 is 2. So this is 2 cube root 3 minus 9 cube root 3. Inside the parenthesis, I get cube root 2, parenthesis, negative 7 cube root 3. So this ends up being the same problem as we did up here. This negative 7 times 1 is negative 7. And then the cube roots multiply together. 2 times 3 is 6. So that's the cube root of 6. Awesome. All right. And then the last one. We got to break it apart. So 108 is 27 times 4. So cube root 2. Whoa, what am I doing? Cube root of 2. Then in parentheses, That's cube root 27 times cube root 4. So that's 3 cube root 4 plus, and then 135 is another 27. So that's 3 cube root 5. Well, those don't add together. Don't get fancy. That's not cube root 9. Leave them separate. Now I got to distribute the cube root of 2. So you just multiply all the numbers on the outside and the numbers on the inside. So 3 times 1 is 3, and that's cube root 8, because 2 times 4 is 8, plus 3, and then cube root 10. Okay? Cube root of 8 is 2. You're always looking for lowest terms. Cube root of 8 is 2. So 3 times 2 is 6. So 6 plus 3 cube root 10 is how I would write that final answer. So yeah, guys, for freshman level math, that's about as tough as it gets. So if you can get through this with a pretty good grade, you should be proud of yourself, because these are pretty hard. All right. I wish we could make them easier for you, but we can't. You're the one doing the division, so keep working the best you can. All right. Nice job, guys.